Okay, we're going to look at ethers now. And an ether is an oxygen that's in between two different or potentially the same R groups. And so we're always focusing on that central oxygen. And the way that we name it is we look at how many carbons are around it. So here we go. Draw the full structural formula. And then I can count. So on this side I have 1, 2, and on this side I have 1, 2, 3. I know that 2 has a prefix of eth or eth, and 3 is prop. And so the way this goes together is I'm imagining this like a group on a main chain and a group on a main chain. And we know that when we've got a group on a main chain, we have the ending part of the name is a YL and a YL. And then we want to put this all together. This nice oxygen in the center is part of our name. The ether is going to go at the very end of my name. And then I have to alphabetize. So if I think through my alphabet, I know that E comes before P. So I'm going to say that this is ethyl propyl ether. Ethyl propyl ether. Sorry for the extra space there. Ethyl propyl ether. Let's get this a little bit prettier by moving it there. There we go. Ethyl propyl ether. Now let's try going the other way. Let's say I have a compound that is called dipentyl ether. So if you notice, this is a little different than the last one. The last one had 2 different parts of the name. This one has just a pentyl with a di. So this is saying that rather than doing a long name where I say pentyl ether, it's saying that I'm going to have 1 pentyl on one side of the oxygen and 1 pentyl on the other side of the oxygen. So I'm going to put my oxygen right in the middle because anytime I see ether, I know that I'm going to have oxygen right in the middle. And then I'm going to do pentyl on either side. And on this one, I'm going to do a semi-condensed structural formula. So CH2, 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 CH3. And the same going the other direction. I'm going to really condense it this time. So CH2, I have that 1, 2, 3, 4 times, followed by a CH3 on the end. So that's a semi-condensed structure or condensed structure formula with the dipentyl ether. If I'm looking to make that into a line angle diagram, which I know many of us are still working on, remember that the ends of lines are where my carbons are. So I'm going to have 5 carbons in a row. 1, 2, 3, 4, 5. And then I'm going to have that oxygen. So going up here, but where we would normally have a carbon, we put that oxygen there. And then I've got 5 carbons on the other side. So again, that oxygen is the part there. Here's my first carbon. 2, 3, 4, 5.